Imagine traveling to the farthest reaches of the universe. Think about visiting distant galaxies, places where no human has gone before. What if we could do it in an instant? What if there were shortcuts through the fabric of space-time itself? This is the tantalizing promise of wormholes, theoretical tunnels that could connect distant points in the cosmos. The idea of wormholes has captivated scientists and science fiction writers for decades. It's a concept that stretches our understanding of the universe to its limits. Could these cosmic shortcuts really exist? And if so, what secrets might they unlock about the nature of reality itself? Our journey begins with Albert Einstein, whose theory of general relativity revolutionized our understanding of gravity. Einstein showed us that space and time are not separate entities, but rather a single interwoven fabric called space-time. And just like a fabric can be bent or folded, so too can space-time. This bending of space-time is what we experience as gravity. Massive objects like stars and planets create warps in space-time, causing nearby objects to be pulled towards them. But Einstein's equations also allowed for the possibility of much more extreme distortions. Distortions that could create tunnels or shortcuts through the fabric of space-time itself. These theoretical shortcuts are what we call wormholes. Picture a piece of paper, folded in half. Now imagine a tiny ant crawling from one side of the paper to the other. The ant could take the long way around, traveling the entire length of the paper, or it could take a shortcut, burrowing straight through the fold. This fold, in essence, is a two-dimensional representation of a wormhole. In reality, wormholes would be much more complex, involving multiple dimensions and incredibly strong gravitational forces. But the basic principle is the same. A wormhole is a shortcut through space-time, connecting two distant points that would otherwise be separated by vast distances. To visualize a wormhole in 3 dimensions, imagine a sphere with a hole in the center. The surface of the sphere represents space-time, and the hole represents the wormhole. An object entering one end of the wormhole would emerge from the other end almost instantly, having traveled a much shorter distance than if it had gone around the outside of the sphere. Of course, this is just a simplified analogy. In reality, wormholes would be much more complex and dynamic, constantly shifting and changing under the influence of extreme gravitational forces. To understand how wormholes might be possible, we need to delve deeper into the strange and wonderful world of Einstein's general relativity. This theory, published in 1915, remains our best description of gravity, and it has passed every experimental test thrown at it. One of the key insights of general relativity is that gravity is not a force in the traditional sense, but rather a manifestation of the curvature of space-time. Massive objects warp the fabric of space-time around them, and it is this warping that causes other objects to move towards them. Imagine a bowling ball placed on a trampoline. The bowling ball represents a massive object, and the trampoline represents space-time. The weight of the bowling ball causes the trampoline to sag, creating a curvature around it. Now, if you were to roll a marble across the trampoline, its path would be bent by the curvature created by the bowling ball. This bending of the marble's path is analogous to the way in which gravity affects the motion of objects in space-time. Einstein's equations allow for the possibility of space-time being curved and warped in extreme ways, potentially forming tunnels or shortcuts that connect distant regions of the cosmos. These theoretical tunnels, known as wormholes, could provide a means of traversing vast cosmic distances in a fraction of the time it would take to travel through conventional space-time. Imagine stepping through a swirling vortex of energy. You emerge on the other side, billions of light years from Earth, greeted by a vista of alien stars and planets. This is the dream of wormhole travel, a journey through a cosmic shortcut to the farthest reaches of the universe. While the idea of traversing vast cosmic distances in an instant is incredibly alluring, the reality of wormhole travel is likely to be far more complex and challenging than we can currently imagine. For one thing, the gravitational forces at play within a wormhole would be immense, potentially tearing apart anything that dared to enter. Furthermore, the very act of traversing a wormhole could have unforeseen and potentially catastrophic consequences for the fabric of space-time. It's possible that wormhole travel could create paradoxes, violating the fundamental laws of causality that govern our universe. Despite these challenges, the possibility of wormhole travel remains a tantalizing prospect, one that continues to inspire physicists and science fiction writers alike. The quest to understand wormholes is ultimately a quest to understand the fundamental nature of space-time itself, a journey that could unlock some of the universe's most closely guarded secrets. If wormholes exist, they could reshape our understanding of the universe and our place within it. They could provide shortcuts for interstellar travel, allowing us to explore the cosmos in ways we never thought possible. Imagine visiting distant star systems, witnessing the birth of planets, or even encountering other intelligent life forms. Wormholes could also serve as cosmic time machines, allowing us to journey through time as well as space. By traveling through a wormhole, we might be able to visit the past, witnessing historical events firsthand or even interacting with our ancestors. However, the possibility of time travel also raises a host of paradoxes and ethical dilemmas. If we could change the past, what impact would that have on the present? And what are the implications for free will if our actions are predetermined? While the idea of wormhole travel is incredibly exciting, there are many challenges to overcome before it could become a reality. One of the biggest challenges is the sheer amount of energy required to create and maintain a wormhole. According to Einstein's equations, wormholes would require a type of exotic matter with negative mass energy density. This exotic matter is purely hypothetical, and we have no evidence that it exists in the real world. Even if we could find or create exotic matter, there's still the issue of stability. Wormholes are thought to be incredibly unstable, prone to collapsing in on themselves, faster than the speed of light. This means that even if we could create a wormhole, it's unlikely that we could keep it open long enough for a spacecraft to travel through it. Some physicists believe that we might be able to create our own wormholes by manipulating gravitational fields. This would involve harnessing energies far beyond anything we can currently generate. However, the theoretical framework for such an endeavor is still in its infancy. One possibility involves using powerful magnetic fields to create microscopic wormholes. These tiny wormholes would be far too small for humans to travel through, but could potentially be used to send information faster than the speed of light. Another idea is to search for naturally occurring wormholes that might already exist in the universe. These primordial wormholes could have been formed during the Big Bang, and if they're large enough and stable enough, we might be able to use them for interstellar travel. Assuming we could overcome the technological hurdles of wormhole travel, there are still many unknowns and potential dangers to consider. For example, we have no idea what the conditions would be like inside a wormhole. The intense gravitational forces and radiation could be lethal to humans, and there's always the risk of encountering something unexpected on the other side. Imagine emerging from a wormhole only to find yourself face to face with a hostile alien civilization, or a cosmic horror beyond our comprehension. Another danger is the possibility of getting lost in the vastness of space-time. Wormholes could lead to parallel universes or other dimensions, and there's no guarantee that we could find our way back home. Despite the challenges and risks, the pursuit of wormhole travel offers too much potential to ignore. The possibility of unlocking the secrets of faster-than-light travel and exploring the universe in ways we never thought possible is a driving force for many physicists. In the coming decades, new telescopes and space probes will allow us to study the universe in greater detail than ever before. We may find evidence of naturally occurring wormholes or discover new particles and forces that could make artificial wormholes a reality. The journey to understand wormholes is a journey to understand the fundamental nature of the universe itself. It's a journey that will push the boundaries of human ingenuity and imagination, and it's a journey that could ultimately lead us to the stars. The vastness of the universe has always begged the question, are we alone? If wormholes exist, they could provide a means for other intelligent civilizations to reach out to us, or for us to reach out to them. Imagine a network of wormholes connecting distant star systems, allowing civilizations to interact and share knowledge across vast distances. This cosmic internet could unlock a wealth of knowledge and perspectives, helping us to better understand our place in the universe. However, contact with an advanced alien civilization could also pose significant risks. We have no way of knowing if other intelligent life forms would be friendly or hostile, and the consequences of a first contact scenario could be profound. The study of wormholes forces us to confront the vastness and mystery of the cosmos. It reminds us that our understanding of the universe is still in its infancy, and there are likely many more surprises in store for us. Whether or not wormholes turn out to be a viable means of space travel, the pursuit of this knowledge will undoubtedly lead to new discoveries and a deeper understanding of the universe we live in. And who knows? Perhaps one day, we will unlock the secrets of these cosmic shortcuts and embark on a new era of exploration and discovery. Until then, the dream of wormhole travel will continue to inspire us, pushing us to explore the boundaries of science and imagination. It is a testament to the enduring human spirit of curiosity and our insatiable thirst for knowledge, a thirst that will continue to drive us to explore the cosmos for generations to come.